Now we're going to look at the next data set, which is the flight delays. And here we're going to look at generating some plots to examine where the delays are. Okay, we already seen this data set in a previous chapter. So we are talking about flights originating from three airports, and the destination, again, three specific airports. And then we have day of the week, month, and weather, and that kind of stuff as predictors. And one way of trying to understand what kind of relationship there is between those flights that get delayed and other predictors like day of the week. Is there a day of the week effect? Is there a destination effect? Is there an origin effect? Is there a departure time effect? Or is there specific to carrier? And so on. So here we're going to see how to generate these plots, and also a plot of a heat map. Here we have three different variables: carrier, day of the week, and I believe this is origin. Okay, and then what is plotted is for each combination, what is the proportion of flights that are delayed. So darker the shade, more delayed. So you can see there are some hot spots for delays like um, Baltimore, and then certain airlines and certain days and certain times are more important or more predictive of flight delay. So these are the two charts that we're going to generate next. Okay, we will read the data in first. So that will be delays dot df. Okay, read CSV flight delays, I believe is the name of the data set. Flight delays CSV. Okay, so run that, and we have the data in. Okay, now we're going to use a list of weekday names repeatedly in several of these charts. So without having to repeat it every time, I'm going to put that into a list. So that would be weekday list. Okay, and we'll put that into say like that: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, so we will have that list, and whenever we need to use that list, we'll just use. We don't have to type the whole thing again. We'll just use that object. Okay. Now we're going to develop these bar charts, and we want them in a grid like 2 columns and 3 rows. So we'll set that up here as par. Okay, and we have the MF row. We have to give that as a list. How many rows and how many columns? So we want 3 rows and 2 columns. Okay, and then once done, we want to put it back. So we'll do par MF row equal to C1 comma 1. Okay. So now whatever plots that we're going to prepare between these two will be displayed in 3 rows and 2 columns. Okay, now we want, okay, remember, let's take a look at what we want to generate. Okay, so we want average delay, right? We want average delay grouped by day of the week. Okay, average delay grouped by day of the week. So there are a couple of ways in which we can do. We did this way back in chapter 3. We used group by procedure. So here we're going to use a different one. So we will capture the generated information in this object, and what we're going to do is to use the aggregate function. Okay, so now aggregate function, whatever that we give as the first parameter, okay, so that's going to be the data, and whatever aggregating function we want to apply, that will be applied to each and every column of that data set. So if you say delays.df, okay, and then after that we're going to specify what needs to be done, and whatever that we need to do, that will be applied to each and every column of delays.df. But we don't want that. All we want is to look at the flight delays column, and we want the proportion of flight delays. So that will be flight status. Okay. But remember, flight status is not a numeric variable, so we cannot compute like a mean or a sum or whatever. So because it's either delayed or on time, right? So what we need to do is to convert the values into numerical values. Okay, but in the case of aggregate, a true value will be evaluated as a numeric value of 1. False will be evaluated as a numerical value of 0. So if we can say, if we can compare this, okay, so compare operator is 2 equal signs, then say delayed, right? Now what this will do is each row, okay, each row of flight status, okay, so you see whether it is delayed or not. If it is delayed, so that's a true statement, so value will be 1. If it is not so, if it is not delayed, then it is false, so the numerical value will be 0. So that's the data that's going to get computed, okay, whatever way that we want to compute here, and we now going to specify how to aggregate. So in this case, we don't want to simply compute the proportion of delayed for the entire column. Okay, we want it by weekday. So we want to sort this all the Mondays together, okay, all the Tuesdays together, all the Wednesdays together, and within each of those weekday, we want to apply the aggregation, whatever that we want to do. So this by should be a list. So we say list, okay, and then provide all the variables that you want the data to be sorted by. Okay, here we want to sort only by weekday, so it is delays day underscore week. Okay, so now we know what is the data and how it should be grouped. Okay, and then what is the numerical aggregation that we want to do? You want to sum it or median or mean, or we want proportion of flight delays, right? So the delayed flights are coded as 1 and on times are coded as 0. So if you take an average of this column, and that will give you the proportion of delayed flights. So I'm going to simply say mean. I want the mean of that data column. Okay, and then it's a good idea to say what should be done to missing values. So if the missing values, remove na.rm missing value remove, and you want to set that to true. Okay. Now if you run this, okay, it'll first convert the status to 1 for delayed, 0 for not delayed, and then group them by day of the week, then remove all the missing values and then compute the mean. Okay, you run that. Okay, and if you look at the AGG, you see 1 through 7. So the columns are group dot 1 is the group variable, x is the aggregate function that was applied. Okay. Now we can rename the columns here, but okay, so that's okay. So we will do bar plot, bar plot. Okay, what do you want the plot to be? You want to plot the second column. That column is what we want to plot. So AGG, okay, you want all rows the second column. That's what we want to plot. Okay, and here you see the plot, but let's give it some more formatting. So we want xlab equal to, so this is the base, bar plot is part of the base R, so you have xlab equal to for label. In ggplot it will be xlab within parentheses. So we say day day of week. Okay, and ylab is average delay. Ylab equal to, well, actually it should be proportion delay percent, so let's call it percentage delayed, right? All right, let's see how this one looks. So day of week, percentage delayed. Okay, but the weekdays are not labeled. So let's on the okay, so on the parameter or the option for that is names.arg. So we say names.arg equal to, you want Monday, Tuesday through Sunday, and that's what we set it up as a week day list. Okay, so there we have it.